Hi, everyone. I'm Killian. I'm as Monica mentioned, the principal data scientist at Assurance IQ. And I want to talk a little bit about generative AI and sort of what we've learned over the last couple of months working with generative AI. When I think about this topic, I really think about what we do at Assurance IQ. So we talk every year to tens of millions of customers on the phone, trying to understand what are the right insurance products that they need, and then finding that product, and then also selling that to them. That also means we have millions of calls in our database, transcribed and saved. That's a huge and really exciting knowledge base for us, but it's also really, really unstructured. So what that means is in order to leverage all the insights that our customers give us there, we would need to either spend a lot of time working through traditional NLP methods, or we just spend hours listening to calls and understanding what our customers said on those calls. And so in the traditional spirit of, instead of trying to do something manually for 3 hours, I want to fail automated for 3 days, once I sort of got into the generative AI space, thought, the thing I really want to do is I want to fine-tune a large language model to extract insights out of our transcripts and understand what our customers are talking about. Now, mind you, this was before all the big vendors came out and made one-click data upload and fine-tuning possible. So this was really just me, some code I found on GitHub around this works on my machine, and a GPU, obviously also not the right GPU for this massive task, trying to understand how can I fine-tune this model to extract insights out of this unstructured data. And so as you can imagine, that didn't go as fast and as well as I imagined. So I spent quite a bit of time and quite some evenings there trying to figure this out. And I was sitting there working through my code. I didn't understand what code was trying to do. My code didn't understand what I was trying to do with it. My GPU didn't know what either of us wanted to do. But then it worked. And I had this large language model summarize a 60-minute conversation and extract the most valuable insights in less than 20 seconds. And that was really this childish joy of seeing how this technology can really benefit our customers and benefit our unstructured data and knowledge extraction that really got me excited and also got us starting on this journey of using generative AI solutions. And so with that, I want to talk a little bit about the lessons that we've learned in that. Since that sort of time, a long time ago when I was doing on my own, we've come a long way. And I'd love then also, if we have time at the end, to hear from you what you might have learned in lessons, and also maybe just have a conversation around if you agree or if you have different lessons learned. But before we do that, I want to talk quickly about what we do at Assurance. As I said, Assurance, we offer personalized guidance that makes finding and using insurance easier. Our mission is stated as helping consumers improve and protect their personal and financial well-being. And we do that through data science at its core. So we have our customers, and our core data science recommendation function is to find the right products for these customers. We do that through digital channels. We also do that through our agents, which are these conversations that I just talked about on the phone. And we sort of summarize all of this as being the best of art and science, because on the one hand, we have our agents that can have that emotional connection with our customer and talk to them in the moment and understand the needs. And then on the other side, we have our technology that enables us to scale this personalization to people and at a cost that is far more affordable to everyone than it would usually be without our technology capabilities. And the cool part about it is we were also founded on data science. So data science is really something that spans all aspects of our business. We have our core recommendation engine, which is run by our data science team. We have our day-to-day optimizations that our data team supports. And then we support any form of analysis and strategic decisions that our company makes. For this, obviously, I'm standing here on stage because we're using Starburst, so big shout out to them. And our amazing data engineering team is also here in the crowd today. All of this wouldn't be possible without them. And we're working a lot with the data mesh and sort of the principles of data meshes in order for us to serve all our data and serve our analytics. What that really means is, for us, across the different domains that we work in, data comes in all shapes and sizes. So at the core, we have our core business metrics that feed our main dashboards and feed our main reporting. And then we think about our data being in different domains. And these domains have very, very different shapes and sizes of the data that they offer us. So just as one example here on the left, you have our recommendations, which is very like traditional SKU unit product information data, tabular form, sort of something that you're very familiar with as a data team probably. And then on the other side, we have our customer experience, where we have the conversations, the interactions, transactional information, stuff that gets just really, really interesting, but also really, really hard to wrangle, especially when we go into this unstructured data set. But generative AI really is what we see as the thing that can enable us to get value from this data. So the standard metrics, and I'm saying they're easy to track, by all means, standard business metrics already have their own host of problems, and it's very, very hard to generate like a good set of core business metrics and keep them up to date and keep them live. That's like very aware. But even with that, it becomes even harder to understand the actual customer experience. On the one side, we have our outcome metrics like conversion or retention, but what ultimately drives that is the experience that we give to our customer, like the rapport that we establish, the product fit that we create, and the satisfaction that we give our customers. And so with that, this part of our metrics is hard to measure the experience, and that's where we're really diving into the generative AI. And so specifically, I want to really dive into what we've done here. This goes a little beyond my example of my code back, one evening. This is a scaled up version of that. And what we've done here is we've really taken our conversations and used generative AI to score them. And as you can guess, we're specifically working with large language models. And so what I really want to talk about is how this large language model interacts with the data that we have, and then what we've learned from that. Ultimately, our LLMs pull from our data lake from multiple domains in a very similar way how any of our analysts or any other tools would pull data out of our data lake. In this case, because we want to score our conversations, we have call transcripts that we really care about that sit in the customer experience domain. These transcripts are very sensitive data, so we really need to make sure that the large language model has the right permissions, and that also the people accessing the large language model has the right permissions in order to work with it and in order to work with this data. In addition, we want to have some contextual data, and then ultimately what we provide is the instruction for scoring our calls and extracting the information out of these transcripts that we want from the experience and from the interaction that we've had with our customer. So from there, the LLM takes all our instructions. It takes the data that we've given it around our information of the calls and the customer experience, and it scores. And the great part about this is it doesn't only score, because language models have the ability to also provide you their train of thought. It also gives us the reasoning of why this score is a good score or a bad score. And that is really key for us. We don't just care about a sentiment score that you could already generate with traditional methods. We care about the why. Why is this happening? And are there new methods that we can work on to train our agents and to train our customers that we're seeing in the trends of why these scores are coming up the way they're coming up. And I gave a small little example there in the bottom right-hand corner. In this example, we have a score of 75%, and then you can see the reasoning of why this large language model, given our context and given the data we gave it, believes that we are giving a 75% customer experience. Our real output obviously looks a little bit different. I unfortunately can't share that, but this is very close to what we do with these models today. And now then, I think a very, very natural next question would be, well, this is all great, but that score could be hallucinated, and that reasoning could be also hallucinated. So how do you put in the right checks, and how do you really control for what is happening with the output of this model and make sure that also not everyone is accessing that? Cool part about that is, with our data mesh approach, the scoring and the reasoning being already in our data lake, we add our traditional normalization and recombination layer on top of it. Obviously, for a large language model, it'll look different how we evaluate if the score and the reasoning is sound to surface into our reporting layer and into our BI tools. But ultimately, it is the same approach that we have as if we were to extract, load, transform any other type of data. It is generated by this large language model. So we did this. What did we learn? And this is really the part that I think is probably the most interesting for all of you. And if you have also additional thoughts, or if you have other lessons learned, or if you disagree or agree, would love to talk more about that if you have either time after this session or as you were walking around the conference. The first lesson is a strong test and learn environment is key. So what that means is we don't know yet, and we don't know always, if the large language model, if the Gen AI tool will be the right task for what we're trying to do. But we got to try it out. And it's so easy to try out, especially with how we're interacting with these models with natural language, that we really need a space where we can quickly spin up new experiments and spin up new tests. And if they work, continue on into production use cases, or spin them back down if they're not really useful. And I really want to drive this home because we're talking here about a test and learn environment. So a place where you can play around, where you can quickly get access to the right permissions. You can quickly find a good way to integrate this with your existing data lake and with your existing reporting. It's not trial and error. This is really about purposeful having a hypothesis and then having a quick way of testing it, rather than just randomly throwing a prompt into a model and randomly throwing some data into it, and then just hoping that it'll work out. Second one is generative AI is just another tool working on the data lake. Now, I'm vastly oversimplifying and formulating it in a very provocative way. The piece here that I don't want to diminish is generative AI as a technology is amazing, and it's astounding that we've gotten this far with all our capabilities, and the research behind it and how we've created all these models is outstanding. If we take a step back from a business value perspective and how these models interact with our data lake, they are fundamentally not different from any other approaches. So what we've seen is that if we have the right foundations in place from our data lake that go around the data mesh, that go around sound reporting, go around data contracts that you maybe heard Chad talk earlier about today, then these models can be successful in operating on our data lake and operating with our data lake. Otherwise, it's going to be hard, and we're going to run into the same challenges of data cleanliness and data issues that we would with any other tool, but also with any other person interacting with our data lake. And that's really important for me to think about this human versus generative AI analogy, not because of any replacement, but because there are two key aspects. One of them, to me, is the data mesh principles, the generative AI model. It also works in a domain. In this case, our Gen AI model worked in the domain of customer experience. We might have a different model, working in a different domain around recommendations. And in a similar way, analysts, data scientists, people cross domains, work in domains, and interact with one another. So the access patterns and fundamentally how we work there is very, very similar. The second one is generative AI, just as humans and all of us, and me myself with maybe some typos you might have found in the earlier slides, we all make mistakes. Which actually brings me to our third lesson, which is generative AI is just another predictive model. And models make mistakes. And this to us was a really key lesson learned, because ultimately the output looks really convincing. And we all know that, especially when we go into tools like ChatGPT where we get the English language result. But it is a predictive model. So with that, we need to consider error rates. We need to consider any type of failure that these models have, any type of biases that these models have, and we need to monitor these, alert for these, or proactively work against them. But this framework of thinking about it as it is another model forces us to think about that, rather than it is generative AI and completely separate from any other data science solution that we've built. If we would think about it that way, we would be not applying the same ideas of controls, of guardrails that we need to implement. The guardrails will look different, and we can maybe also talk about that at some point. But the key part here is we need to treat it like a model that makes predictions. Those predictions have errors, and so we need to account for those errors. And ultimately, the question is, given the performance and accuracy of my model, is it suitable for the task, for the thing that I'm trying to solve? And that's it. Those are our three lessons. I would say sort of the overarching theme that we've really seen is that starting with simple use cases, things like finding insights, extracting insights, really helps us to get our lessons learned quickly, and really helps us to then iterate on that and build the underlying foundation that allows us to then move on to the next level and move on to the next level in using generative AI in our data science world. The three lessons I was talking about: strong test and learn environment. Gen AI is another tool that is working on the data lake, and it's another model. So models make mistakes, and we need to account for that. I hope this was useful. I hope this was exciting for you. I believe also, Monica.
We have questions. Does anyone have any questions? I'd love to run the mic around and okay, perfect, great, lots of questions.
Thank you. How are you defining insights from an LLM perspective? Because I think of insights as a function of contextualizing data and the analysis to your business needs, the information that you're trying to identify that's actionable and just so fundamentally contextual. And for one thing, the models are, and the actual output is contextual, whereas LLMs are kind of just text. So I'm working on an insights engine myself, so this is something I'm wrestling with a lot, just kind of the function of information extraction when we talk about insights. So just any thoughts on that whole bit? Yeah,
it's a really good question because of, I think what you were talking about there was really the tension between it generates text versus is it actually creating insight, and how can we use that? And I think the way we think about it is from an analytics and insights perspective, it is another tool. The same way insight through a logistic regression is a tool to understand what is happening in your data. And so for some cases that might be really useful, but for other cases it's just not the right tool to generate insight. And so it really goes back to, is it the right purpose and is it the right function that we're trying to extract insight from? Or could even simpler methodologies do? We still have so many other predictive models that run and that help us understand our customer. This is just unlocking for us the unstructured data side of it, if that makes sense. Great.
So my question is, we are talking about Starburst and the LLM here.
Yeah.
Can you give more detail how Starburst help you to build a data lake? Because we all can train model in S3 or AWS. I want to know a little more detail. How do you leverage Starburst here?
Yeah.
Integrated with your LLM.
Yeah. Also great question. And I think I also think that question is really interesting because it goes back to what we noticed as we were working with these models, because training, fine-tuning, deploying, calling these models is one unit of, this is where a predictive model or a generative AI model lives. The other question for us is, what does it operate on? And it operates on our data and on our data lake and interacts with our data lake, both writing into our data lake, but also extracting information from our data lake, and is really an agent, just like other tools that work with our data lake, to ultimately get the information and get the context it needs to produce a useful analysis. And Starburst is our data lake. And with Starburst together, we've been working on setting up our data infrastructure in a data mesh approach. A lot more details and maybe a lot more information, I would also recommend talking to our data engineers that are sitting over there. They'll have a lot of insight into more of the details, but I'll say what we've learned really is, if we have a data mesh approach to how we set up our data, we didn't really need to change anything about our data lake. Generative AI didn't require us to fundamentally rethink how we've built our data lake or how we've structured our data, because it goes back to the same foundational principles of having your data set up in domains and having your data available in the right way and having the access patterns that you want and having the governance around it. All of that was the foundations of our data lake that have been there. And generative AI hasn't really changed those principles for us. I hope that makes sense.
So there is a question how do we leverage LLMs when, say, for example, we cannot actually expose the data to LLM, but all that we have is metadata, and that too changes from client to client?
Yeah, could you be more specific on
So say, for example, we are building an end-to-end data analytics platform.
Yeah.
Right? And in that, how do you interact with the metadata and the data is something that is very intrinsic to the platform, right?
Yeah.
At how the metric is cut by, slice and dice by the categorical columns and all those things.
Yeah.
Now, say, for example, if I want to layer it with a natural language, and that is where I'm trying to use, say, for example, LLM, I cannot expose the data.
Yeah.
Show them the data, but I can expose them the metadata.
I see.
And if that is the way I want to go about it, where I'm not actually exposing the data,
Yeah.
that metadata itself changes from client to client, industry to industry.
Yeah.
How do I leverage LLM and how do I figure out the ROI on that?
Yeah. Phenomenal topic. I think also given the time, I would love to connect after the session here and love to talk more about that use case. But yeah, I think it's a really interesting question of how do we do this on the metadata, not the actual data.